In these problems, we are looking at graphs of functions, some pretty strange looking functions with some holes and discontinuities, and trying to determine where it's differentiable and where it's not. This idea of the derivative of differentiating a function is finding the slope at that point. So if you can easily draw a tangent line, then it's probably differentiable. But there are places here where that would be hard to do. If it's got a hole, how do you draw a tangent line of a hole? If it's defined, but it's defined at a point that's distant from the whole rest of the line, that doesn't make sense. You can't really draw a tangent to a point. If it's got a big discontinuity like this, where would you draw the tangent line? I don't know. And then also at sharp turns, corners, or kinks, it's not really clear how you would draw the best tangent line for that either. So all of those are examples of places where a function isn't differentiable. Okay, so let's see how they've organized this problem. A lot of boxes to fill in here. It says use the graph to complete each of the following parts. From the choices of values of x below, choose all at which f appears to have a corner or kink. And I think the only place that's happening here is at x equals -2. That's a sharp corner. So that would be here. And from the choices of the values listed below, choose all at which f appears to have a discontinuity. So I think there are discontinuities here because there's a hole in the graph, here, as well as here because we have to jump down. So that is -1, 1, and 4. So -1, 1, and 4. And that kink is not actually a discontinuity because you could draw that without lifting up your pencil. And that's kind of the way to think about continuity. So it's continuous there, but it's not differentiable. All right, and then C says, from the choices of values of x below, choose all at which f appears to have a vertical tangent line. Do we have any vertical tangent? Oh yeah, look at this. Hadn't even noticed that. When the function becomes perfectly vertical, a tangent line would have a slope that's undefined. So that is another place where the function becomes undifferentiable. So, and that looks like at x at 3. Are there any others here? Doesn't look like it. All right, so x equals 3. From the choices of the x values below, choose all which f appears to be differentiable. So not at 3, 4, 1, -1, or -2. So not at -2, -1. I don't think we checked 0. We'll double check these when we look on the graph. We did check 1. Did we check 2? Doesn't look like it. And we did check 3, and we did check 4. So we want to check 0 and 2 here, just to make sure. So at 0, we are down here between -3 and -4, and you've got a smooth, continuous function all around 0, no holes in the graph, no sharp turns, so that looks good. And at 2, we're up here, but same thing, smooth, continuous function. So definitely differentiable at 0 and at 2. So that is a little bit of work with identifying where the graph of a function is differentiable.